Hi, my name is P. Harikrishna and I am working as assistant professor in Annamachaya University located in Rajampeta in Department of AI/ML. Today I am giving demo topic on supervised and unsupervised learning in cyber security. Coming to the first slide, that is introduction to machine learning. In machine learning, it builds models that identify patterns in large data sets. It learns from past data to make future predictions, and it does not require explicit programming for every rule, and the performance improves as more data is provided. It detects spam emails automatically, and it identifies malware and ransomware attacks. It monitors network traffic for suspicious activity. Coming to the next slide, that is types of machine learning algorithm. In these types, first one is supervised learning, and second one is unsupervised learning, and third one is reinforcement learning. Coming to the next slide, that is the definition of supervised learning. In supervised learning, it uses labeled data. Labeled data means it provides input and output pairs. It is used for classification and regression problems. Coming to the next one, that is supervised learning in cybersecurity. That is used for spam email detection, malware classification, phishing website detection, and intrusion detection system. Coming to the first one, that is malware classification. Malware means malicious software designed to damage or it disrupt or gain unauthorized access. And coming to the second one, that is phishing. Phishing means it is an cyber attack which is used by the attackers for trick users into revealing sensitive information like password or bank details by pretending to be a trusted source. And coming to the last one, that is intrusion detection system. In intrusion detection system, security systems that monitors network uh, network traffic or network system activities to detect unauthorized access or attacks or suspicious behavior. Coming to the next slide, that is common used supervised algorithms that are support vector machines, decision trees, random forest, neural networks. Coming to decision trees, internal nodes, branches, leaf nodes are used, and the leaf nodes are treated as the final predictions, and branch nodes are used as uh, shares. And in random forest, uh, most of the majority of the voting system that final majority of the voting system will be treated as the final prediction. These are the commonly used supervised algorithms. Coming to the next one, that is advantages of supervised learning. The first one is high accuracy quality labeled data. In high accuracy quality labeled data, it provides accurate results when trained with quality labeled data, and its performance can be measured by using metrics like accuracy, precision, recall, and F1 score. It is effective for known attacks. That is, it works very well in detecting previously identified threats such as spam, malware, and phishing attacks. Coming to the next slide, that is limitations of supervised learning. Uh, in supervised learning, it requires large labeled data sets where it needs a large amount of labeled data, which is time consuming and costly to prepare. And in this second limitation is poor at detecting network attacks. It cannot easily identify zero-day or unknown threats like that. It were not present on training data. And coming to the third limitation, that is overfitting risk. In overfitting risk, it may perform well on training data but poorly or new or unseen data if not properly trained. Coming to the next slide, that is unsupervised learning. In unsupervised learning, it uses unlabeled data. It finds hidden patterns and structures. The main task is clustering and anomaly detection, mainly used for clustering and anomaly detection. Generally, it depends on hidden patterns and groups, and the main intention is it is mainly used for clustering and anomaly detections. Coming to the next slide, that is unsupervised learning in cybersecurity. Generally, it is used for anomaly detection in network traffic. The major key points are zero-day attack detection, user behavior analytics, and fraud pattern discovery. Coming to the first one, that is zero-day attack detection. In zero-day attack detection, it is a cyber attack that exploits a software vulnerability before the developer has released a fix or path or patch. Coming to the second one, that is user behavior analytics. In user behavior analytics, it is one of the security technique that analyzes user activities to detect unusual or suspicious behavior that may indicate a cyber threat. And the next one, that is fraud pattern discovery. In this technique, generally we use to find the persons who are attempting to make or trying to get unauthorized access. Generally they are using someone's username or password to get into their attacks, and they want to steal their data or sensitive data like passwords or logins information. Like these are the examples for that fraud pattern discovery. Coming to the next slide, that is common supervised algorithms. The common supervised algorithms are generally K-means clustering, DB scan, hierarchical clustering, and autoencoders. These are the common unsupervised algorithms. Coming to the generally unsupervised algorithm, it uses unlabeled data. It is used for find hidden patterns and groups, and it is mainly used for clustering and anomaly detection. Based on these data sets, we will apply this K-means algorithm, DB scan, hierarchical clustering, and autoencoders. Mainly we use K-means and DB scan. These are the topics involved in our syllabus coverage also. And for this, we trained some labeled data set. Generally, unsupervised is used for zero-day attacks. Coming to the next slide, that is advantages of unsupervised learning. That is no label data required. In no label data required, it can detect unknown or new attacks. It is used for exploratory data analysis. In no label data required, it works with raw and unlabeled data, reducing time and cost of data preparation. And it is used for detecting unknown threats. It can identify new or zero-day attacks by detecting abnormal patterns. And it discovers hidden patterns and find meaningful structures, clusters, or relationships in data automatically. These are the advantages used in unsupervised learning. Coming to the next slide, that is the limitations of unsupervised learning. In unsupervised learning, it is difficult to measure accuracy and high false positive rate. It requires expert interpretation. It is generally there are no labeled outputs. It is hard to do measure model performance precisely. In high false positives, many incorrectly classify normal behavior as abnormal, leading to unnecessary alerts. Abnormal means generally, for example, generally an employee's login at usual regular timings, that is 9 a.m. and log out at 6 p.m. Whenever an employee tries to log in at midnight 12 p.m. or 1 p.m. and tries to steal the data related to the organization and transmitting that data to someone else beyond the organization employee, it will be treated as an abnormal behavior of an employee. This is an example for this abnormal. Coming to the next slide, that is a comparison between supervised and unsupervised. In supervised, we use labeled data set, that is it will provides both input and output for classification and regression. Coming to the unsupervised, it uses unlabeled data sets. In supervised learning, it detects known attacks, only known attacks. Whatever the data we provide for that, it will be classified based on the label data we provide. In unsupervised, it detects unknown attacks, whereas it does not need label data. These are the common comparison between supervised and unsupervised. Coming to the next slide, that is case study. Uh, for example, one case study example, that is a bank fraud detection system. In this, we use supervised model for detecting known fraud patterns. Unsupervised model identifies unusual transactions and hybrid approaches security. In this, uh, bank processes millions of transactions daily. Detecting fraudulent transactions manually is difficult, and it consumes more time. Uh, Supervised machine learning uses trained using historical transaction data labeled data as fraud or normal. Generally, it learns patterns like unusual transaction amount, foreign country transactions, multiple rapid transactions, detect known fraud transactions. These are the case study examples. Coming to the next slide. This is the conclusion. Here we use both techniques are essential in cybersecurity. Both supervised learning and unsupervised learning are essential for modern cybersecurity. Supervised learning is effective for detecting known threats using labeled data, whereas unsupervised learning helps to identify unknown or zero-day attacks by detecting anomalies. And coming to the last point, that is a hybrid approach provides a stronger, more intelligent security protection. Finally, both supervised and unsupervised learning are essential for modern cybersecurity for detecting known threats using labeled data.